Kubernetes service because this is virtual Azure. So we want to talk about Azure, but just so you know, workload identity is really aimed at doing more than just Kubernetes in Azure, but Kubernetes anywhere. So that being said, let's have a look at the agenda. So I will go a little back into what we had before workload identity, just to put some ground base and be sure that we have a common basics. Then we will have a look at workload identity, how it works, what it brings to the table, why it's better than what we had before, and then we will look at the different steps to implement it, and hopefully we will have a demonstration that will be working, because we never know in life. Anyway, that being said, I had prepared I prepared a slide to present myself, but since it was already done, I just have to add that I'm a Final Fantasy fan, which is why you won't see that much picture of me on the internet, because I don't like myself on picture. And usually I try to represent myself with this little character, which is a black mage, not a Jawa in Star Wars. This is very different. One is doing magic, the other is just smelling and stealing robots. I'm not doing that. Just to be sure. Okay, so let's go back to the serious stuff. So, as I said, an introduction about what we had before workload identity and what is the need and the solution that we had to put that in place. Okay, so to start very basically, we will have a look at microservices and how they work together. So as you can see on this schema, which is aimed to be simple, when we have a service that, let's call it service 1, and another service that could be called service 2, usually we want to have authentication and also authorization, auth-n and auth-z, because I'm lazy, that allow us to be as much granular as possible on the authorization and authentication between those services. So what will we have usually is that service 1 would be integrated to an identity provider on which you would get login and password or something similar. And then we also would have service 2, which would be partly or totally integrated with the identity provider for its own control plane, and that would allow us to both recognize the authentication from the identity provider for service 1, but also manage authorization inside of service 2 control plane. Okay, that's how it works. In the past, we had some issue with that because we had to rotate password for service account and stuff like that. And it was not always easy to do. And with the promotion of microservice based architecture, it was not simpler, but fortunately, thanks to the cloud and in Azure, we had some way to do that, because as you probably know, in Azure, without considering containers yet, we have what we call managed identity. I guess a lot of you are familiar with that. And this is exactly what I described earlier, except that the service 1 this time is associated to a managed identity, which lives in Azure Active Directory, and which can be granted access to another service which is also living in Azure through role-based access control and what we currently do with role assignment. Okay, so that's kind of easy because we associate an identity which we don't care about for all the secret and rotation and all of those things, because it's totally managed under the hood by Microsoft on the Azure platform, hence the name managed identity. Okay, that's it's easy, it works fine, and it works only on Azure, so we don't find any more hard-coded secret in application code, and we have less important surface attack for using this identity, because it cannot work outside of Azure, and depending on the kind of identity, it can also work either only on the service, or if on the control on the life cycle of this managed identity. Okay, so that's fine. But then comes the container, because we mentioned that we want to talk about microservices. So what happens when we have containers? Well, first we have some problem because by default, as you probably know, a container is a runtime that is isolated so that we can decouple the process in the runtime from the operating system. So we really have separate let's say landscape. The OS and the runtime are only dependent on the compatibility of the kernel in a Linux point of view, but that's all. Otherwise, there is some isolation. So I don't want to go too much deep into container principles. We could talk about that for hours, but I don't want to do that. Let's just say that by default, we have isolation, but in our case, this is a problem because since we have an isolation from the runtime, if you try to run, let's say, a Docker container in a virtual machine in Azure, you will see that the managed identity don't work that much. And since Kubernetes and Azure Kubernetes service specifically in Azure is working on virtual machine, then we have an issue because we don't have anymore the managed identity proposal as a solution to answer our needs. At first, we had one proposal which took a lot of time to be developed and to be quite stable, but which never reached the global availability state. Sorry. So it was called pod identity. So a pod identity. It was a way introduced by Microsoft product team for AKS to make a kind of correspondence between the Azure control plane and the Kubernetes control plane. Because as you can see on this schema, the trouble that we have is that because the pod is well, containing containers, it's isolated from its host, the node pool in Azure. There's no way that it can knows what is the managed identity, right? So to work around that, we had a product, well, a solution which made a correspondence between the managed identity in the Azure plane with the Kubernetes plane. So we had something somehow elegant, which was using a custom resource definition, which is kind of more and more frequent in Kubernetes. So two objects, an Azure identity and an Azure identity binding, so that we did not fix directly on the pod the identity, but we use a binding so that it would attach the identity equivalent to the managed identity from the Azure plane to the pod. Okay, so it was working fine. It was using CRD, but we had some limitation. One maybe the most important is that under the hood we needed to have something getting all the authenticating call from the pod so that it could redirect that to Azure ID and perform the authentication. So it was not easy to scale. It was not considered that much stable. And for well, let's say that it was not the definitive solution. Okay, so V2 was totally redeveloped and was called workload identity, which is definitely the heart of the topic for today. So which is know that finally workload identity took some time to, well, it's been around for some time. As a matter of fact, it went GA just last week for the KubeCon. It was announced directly in the Kubernetes conference that it was going GA, so that was the good news. And it's really much more broader in terms of federation of identity than was pod identity, because this time, that's why I wrote on the slide, this is a feature from Azure ID from Entra, which means that we are considering the workload identity concept not specifically for Kubernetes, but for all Azure ID, so that it can be used to manage authentication and federation between different identity providers. So we'll have a schema demonstrating that just afterward, but just remember that for now, it's more an Azure ID feature, an Entra feature than just a Kubernetes feature. Second, it's eligible for both managed identity and application registration, which is a good news. Well, at first, it was only available for application registration, and I thought it was not that much a good news because considering pod identity, it was kind of a regression because one was working with managed identity, so no password, and the other was not working with managed identity, so in my head, password. Well, I was wrong. As a matter of fact, the secret for the application registration. We'll have a little look at that moving forward. But just so you know, because we can use managed identity and application registration, that's what I said in the introduction, this is much more hybrid than pod identity was. So indeed, we can use managed identity, so it works fine for AKS. That's what we will try to demonstrate afterward. But we can also implement workload identity for any Kubernetes. Well, not any Kubernetes, there are some requirement, but nearly any Kubernetes not too old in its version. Okay. Another thing that is important to consider, we introduced the concept of workload identity federation. I will go a little deeper in that afterward. But the important things to know is that really it allows to federate different identity provider with Azure ID on a granular object, which is either a managed identity or an application registration. What could I say about that? Let's switch on the next slide and have a look at how it's working. It's working with third-party identity provider, which are OIDC compatible. That's why we have on the schema the OIDC URL that you can see over there. And how is it working? Roughly, we have an external identity provider and an external workload. This external workload, which can be an application or a microservice, that's what we will do afterward, will request a token to its external identity provider, and then it will get this token from its identity provider and try to access its resource, as you can see on the 6 steps. But before the 6 steps, we have other things. The external workload is able to talk with Azure ID, really, and specifically reach security principle in Azure ID. So it can be either a managed identity or application registration. And this managed identity, or this security principle, because it's federated, it has federated credential, it will validate with the external IDP on its OIDC URL the fact that it accepts it's validated for federation, and it accepts some request with the definition that we will have a look afterward also, and then it will validate. It will be able to reach the OIDC third party so that it can check that the external workload check-in identity on itself is legal. Once it knows that it's legal, it will issue an access token, which will allow the access to the resource, which will typically be an Azure resource on which the access and the authorization will be granted, because this Azure ID principle will be assigned a role-based access control assignment. Okay, that's roughly how it's works. It's not limited to Azure ID. To Kubernetes. It's really a broad federation capabilities that is provided through Azure ID. Okay, but what we care tonight is really how to implement that in Azure Kubernetes service And if some of you are interested in how it's working with other Kubernetes service, well, the good news is that it's quite similar. The only difference will be the security principle, which will change depending on what we have. First thing first, so as you can see on this schema, instead of having third-party identity provider, we have a Kubernetes cluster. In our case, it will be an Azure Kubernetes service cluster. We need to have the capability from this cluster to have the OIDC URL, which is only available since Kubernetes version 1.20. So that means that it can work with any Kubernetes cluster with at least version 1.20. Okay. So because this Kubernetes cluster is able to provide this OIDC URL, it will be acting as the identity provider for a workload running in the Kubernetes control plane. So it will be typically a pod on which we will associate a service account. So no more custom resource definition this time, just classic Kubernetes API objects, so pod and services, service account, sorry. And how it works will be quite similar. We will have an application running in a pod on which we will also configure a service account. This service account will allow us to get the token issued on the fifth step by a validation that occur under the hood. So there are other things for that, which I will try to explain just afterward. But to summarize, in Azure, we will need a managed identity with federated credential. In Kubernetes, we will need a Kubernetes service account and also the OIDC issuer URL for the cluster. And under the hood, what will make it work is what we will install on our Kubernetes cluster. So if it's Kubernetes in Azure Kubernetes service, it will be an add-on. So this is what I will do. I will show you how it's working. This is quite easy, just add an add-on. If you are not in Azure, then you will need to install that manually through classic means of installing open source software with either YAML manifest or Helm chart. I would recommend using Helm chart. It is much more easier to manage, but that doesn't mean that you should not have a look at what is installed by this Helm chart. Anyway, we'll do it the easy way because we are working in Azure, and that's also one of the highlights of that. Azure Kubernetes service is not simple, but let's say that the complexity is not the same on the same level as it is for Kubernetes in general, and a lot of third-party products are really available now as add-on that we can just install through either a checkbox in the Azure portal or in with a command line in AZClear or stuff like that. Okay. Okay, so we'll have a deployment. Just to emphasize how it's working, the managed identity needs federated credential, and I guess that's why it took some time, because it was available, because we needed to be able to put this federated credential on security principle in Azure AD. So it took some time, and as you can see, I have an extract on this slide on how to do that through Terraform, because as it was mentioned during the introduction, I like to do everything with Terraform for automation, so I can keep some control of that. It's not mandatory. You can do that the way you want. As a matter of fact, if you look at the documentation, you will see a lot of things being done through Azure command line. But because I wanted to understand how it was done, I broke everything and try to do that on my way, and that's why I use Terraform. Just so you know, you have the managed identity on which we associate a federated credential, and you can see a few things. The identity is easy to do any way you want to do it. The federated credential is not that difficult to do, but we need to find a few parameters so that we can make it work. So as you can see, we need to refer the managed identity. So that's what is identified with the parent ID. Then we have a subject. We also have an audience, and we also have an issuer. The resource group name, just to be sure that we locate the federated credentials for the managed identity in the proper place in Azure ID, but that's not that important. The important part is the issuer and the subject. So the issuer is the OIDC URL that I will show you how to get in the demo afterward, and the subject is specifying the names, the service account in Kubernetes by specifying the namespace in which the service account is living, and then the service account name. Which means that to make it work, we need to know where we want to make it work in Kubernetes. We cannot create everything beforehand in Azure and then have correlation in Kubernetes. No, we need to understand what we want to give access to from the Kubernetes plan, so that we can create in the proper namespace a service account, and then this service account will be referred in the federated credential in the Azure plan. Okay, so it's work first. Know what we want to get access to, what we want to give access to, and then refer that in Azure so that we can give it access. Okay, so the OIDC URL we'll see afterward, and the audience. I did not take that out of my head. It was referred in the documentation. This is the proper value that is recommended in the documentation of workload identity for Kubernetes. Okay. Next, so just so you know, the demonstration will demonstrate how to give access to a pod, well, to a few pods for that matter, to a key vault in Azure. So to do that, we need another part, which is the CSI Secret provider, which allows us to, similarly to what I explained earlier in the introduction with pod identity, we have a correspondence in Azure and in Kubernetes. In Azure, we have a key vault, and in Kubernetes, we create a specific object, which is the secret provider class, which can refer a set of secrets or certificate or key, for that matter, living in key vault, and it can be granted access to pods living in Kubernetes. What we want to achieve here is the granular security with workload identity. So on the screen, you can see that I used to do that with pod identity. This time I'm not using pod identity, so that's why the value is at false. And then I'm using a client ID, which is referring to the managed identity that I create in the Kubernetes, no, in the Azure plan. So you to identify the pod and service account for those resources, and then associate that to the federated credential. Then we go back to Azure, to Kubernetes, sorry, so that we refer this identity that we created in our case, in the secret store provider. Okay, so that's how it's supposed to be working, which brings us now to a demonstration, because as we usually say, pictures are much more helpful than 1,000 words. So where is my window of the documentation? Okay, so what we will do, I need to reduce this one first, because you won't see anything if I keep that like that. Okay, so as you can see, here are the configuration that I've shown you for the managed identity and the federated credential. If I move back to the Azure portal, which is over there, we should see in this resource group the managed identity, which should be this one. And if we have a look at this managed identity, we should see federated credential over there, which refer to what we had. So you can see here I have the issuer which is defined. I have a name, and I also refer. Let me zoom that because I don't want you to become blind because I have a big screen. You can see that there is a reference to a service account, which is not that much visible, but I will show you that with some command line. Okay. I said also that I would show you how to get the issuer, the URI, OIDC issuer for your cluster. So let's do that. So first, I want to list all my Kubernetes clusters. So let's do that this way. But later it won't work. So I should have one cluster, and it should be up and running because I just started it earlier. And then if I want to show you how to get this OIDC URL, there's the command to do that. I think it is something like that. I can still use the list, but because I know I have only one, I can use GQ to parse this JSON list. And let's type, it should be something like OIDC issuer profile. Be careful with the case of the character. If there is a major A and a major P, it's required. You won't have the information if you're not using it. And as you can see here, I can get this OIDC URL. If I go back to my portal, this is what I did. So it seems to be okay. Perfect. This is how I did that. Okay. I told you also that under the hood, I had some other stuff working on the Kubernetes plane. So let's have a look at that. If I'm having a look at what's living in my Kubernetes kubesystem namespace, let's get a deployment. Perfect. Let's specify kubesystem. And if you look at that, you can see this one. No, not this one. This one, the WI for workload identity, web app controller manager, and that is referring to how workload identity is working under the hood. So how it's working under the hood. This is let me check that. I have the link somewhere in my notes. This is something that is documented in the workload identity documentation. And in this documentation, we have an explanation how it's working. I would like to find this link if I can. So this is not this one that I wanted to show you, but just so you know, as I mentioned earlier, there's the documentation for Entra referring to how it's working in the Azure ID control plane, and that's here that I got the value for the issuer, the subject, and all of that. So this is something that is available on the Azure documentation that I can share with you in the conversation, just to get that. Okay. And then on the documentation of the workload identity federation, we should find the reference to how we configure the object. Let me just find where I put that. I used to have a reference for that. I just don't know where it is yet anymore. I'll try to find it. So we should find something over there. Workload identity federation. Yep, that's not this one that I wanted to show you. Sorry, I lost my link. I just need to find it. Oh, come on. Some sample over there, but this is not the one I wanted to show you. How it works. There's some place somewhere where I can find the documentation. Is it over there? No, this is not this one. Okay, so I will try to find that later. Let's not waste some time. Just so you know, there's some information that help us to configure the workload identity concept, and they're referring to the value that we can find so that we can configure the Kubernetes object. So what we need obviously is a namespace, which I represent here as a template. We also need a service account, and this service account will refer in its annotation. That's what I wanted to show you on the documentation, but I can't find the page yet. We need to specify a reference with the annotation, specifically Azure Workload Identity client ID, and this client ID will be the client ID of our managed identity. Okay. Then we need to associate the pod, well, in our case deployment, but this is the same because in the deployment we have some pod, and the pod are mounted with a service account, which is the service account that we create beforehand. So if I show you a more existing use case, this is the secret provider class that will help us to make the correlation for our key vault. But what is interesting is this service account, which is referring, I prepared that before and I cheated, which is referring to client ID of my managed identity. If I switch back to my managed identity in Azure and I look at the overview, the client ID, as you can see over there, is the same. 5512 CD 444. Let's go back to my object definition. You can see that this is how the service account is linked somehow to the managed identity in Azure, and it gets from what I showed you earlier in the deployment for workload identity, it gets the token through this system in Kubernetes, which is using something called the mutated webhook, so that it can get the token from Azure ID and put that in the volume of the workload identity pod. Okay, so I will try to show you that. As you can see, I have prepared beforehand all the manifest with the proper value. I will just check that I have the namespace that I want so that I can put my resource in it. So I should have a namespace called NS Workload Identity Demo. And as you can see, it's over there. So it means that it's working fine. So if you've seen that in the past, you know that we can just copy paste the path of the folder containing all of our manifest, and then just do an apply and paste the path. And so it should create all my object. Okay, perfect. So now if I go to the namespace, okay, let's check what I have in this namespace. And I should have completion at one point. Okay, so I have one deployment with everything ready and working, so that's fine, because if not, it would mean that it was not working as I was expecting. Let's get some details. as you can see, can we see something? No, we don't see that much things. There's no error, so it means that it's working fine, but you can see that I've mounted a secret store. So that means that it was able to authenticate on that. Then I also have the, oh no, sorry. This is not this one that I should reduce. This is this one. Okay, let's clear that. If I get, how is it called already? This is a secret store. Secret store provider class. So this one is the object referring to my key vault. No, I need to specify the namespace. It's referring a key vault that is also living in Kubernetes, in Azure. So I will show you this one. So this is this key vault. Okay, I have more than one, but look at this one. KV for key vault, CSI for CSI secret store, no, container storage interface, sorry. So in this key vault, I have created a secret, but I cannot see it because I don't have access. So let me change that so I can show you that there is a secret indeed in that thing. Let's add myself. No, just get listed is enough. Okay. Now, if I go back to secret, you can see that I do have a secret that is living in the Azure space. And moving back and going back to that, you can see that I'm referring this secret in the secret store. Okay, so I need to create the secret store, the secret provider class in Kubernetes and specify which secret I want to give access. And then I'm giving access through workload identity by this parameter over there. Okay, and then my service account is referring the managed identity, which should get access to this key vault. We can check that in the access policy, but let's move to that. You can see the CSI workload identity, which has a get and list. Okay, perfect. So we are only able to get and list. And now I have this deployment which contain pods which supposedly are able to access the secret because we mounted this secret as a volume. Okay, and we only use this managed identity to do that, but we want to verify that it's working. Okay, so let's get a pod on that. I should have, oh, this is not what I should have done. Let's that over there. So I have 3 pods in my deployment which are configured so that they can get access to the secret source. So if I look into the pod, we should see the secret mounted in the path that I've shown you in the description. Okay, so let's try that. With the command exec, which allows me to execute inside the pod. That's some code. I will specify the name of my pod. Okay, and I need to specify to a space, and I will try to do ls/mnt because I forgot the path. So I have a secret store. So let's try to do that. Secret with an S, because there might be more than one secret. And as you can see, at this time I have the mounted as a volume the name of the file which is the name of the secret. And so if I try to look at the value of this secret, I should see the value of the secret. This is a secret demo. Let's be sure that it's the proper value, but I have no much doubt anymore. Okay, look at the version. It's working fine. This is the value that I wanted to have. Okay, perfect. So I decorated secret management from Kubernetes so that I can get that to Azure. So that was another topic, but I did that without giving access on cluster-wide attribution. I just granted access to a specific set of pods with a workload identity and a federated credential on an identity. Okay, so that means that definitely with workload identity, I can federate manage identity or service principal in Azure AD so that I can grant them, I can use them to grant access to workload in Kubernetes and be granular. The first example being what I show you, which is give access to a key vault, which is, let's say, a pragmatic approach, because if I don't know how to provider to mount secret as volume, and then the secret will be available. Because I'm more an infra guy than the developer guy, I try to find solution with less development, and that's one of those. Okay, so well, that's all for this demonstration. So that means that I'm at the end of my presentation. So what did we see? We've seen that, well, first, let's remember that workload identity for Kubernetes, for Azure Kubernetes Service, and for Kubernetes in general is GA. Try to implement that on the Kubernetes and Azure Kubernetes Service point of view. We can use that so that we can interconnect a Kubernetes cluster and credential in Azure ID to be granular on access granted, and Azure ID is providing this identity, which also means that we have all the power of Azure ID to secure those federated credentials with, for instance, conditional access, or even potentially some access review that could be arranged on the security principle that we use to grant access to the Kubernetes environment. So there is really some good thing with that. First, we have a much more stable product to give access to pod to Azure ID resources. And second, because this is more control on the Azure ID side, we have, again, all the security built in Azure ID so that we can secure this identity and this hybridization. And again, last, remember that because it's working both with managed identity and application registration, it can be deployed on any Kubernetes cluster with at least the version 1.20, so that we can have the IDC role. Okay, so a very nice feature to be more granular on the access and the identity management for workload in Kubernetes, accessing workload in Azure. And that's all for me. So thanks for your attention. If you have some questions, I'm ready to take them.
So thank you very much, David. If anybody has questions for David, it's okay to come off of mute and ask directly, or feel free to type them into the chat and we'll pick them up there.
If you need some more thorough review, just so you know, I did wrote a written version of this presentation on my blog, so I just shared with you the link. So if you want to reread because you are more a reader than a viewer, then you can have a look at this article.
Very good. Well, we can stick that in the on the meetup site too, so that
Yep.
latecomers can, or even
Feel
on
free.
the YouTube. Yeah.
So no question, I guess.
Well, I guess not. So I guess with that, I'll remind folks that there's a Boston Code Camp this Saturday in the morning, all day, like 9 to 5 or so. And then a couple of weeks after that, there's the Boston Azure Boot Camp, which you can find on meetup.com/Boston Azure. And with I guess last call for questions. And I guess maybe there are no questions. So really appreciate it, David. Thank you. Thank you for
Thanks for having me.
educating us. New feature, keeping us up to speed. And thank you everybody for joining. And Jason, anything to close with?
Nope. Session.
Okay. Yeah, good session. And it'll be posted to YouTube in a day or two.
Yeah, it'll probably be later on tonight.
Very cool. Well, we'll return you to your Friday, David, and everybody else will return to your Thursday. Thanks, everybody.
Okay. Thanks. Have a
Thanks, everybody.
good day. Bye.